Good morning, fifth graders. It's time for lesson 4.2. I'll have you know that I finally got the upgrade, so no more 5-minute fast talking videos. Sorry to Sadie, I told her I had some funny ones today because I had to talk so fast and make it 2 videos, but I decided to redo the video. Excuse me. I'll start by going over the work from yesterday. You were doing 4.1 where you were measuring some stairs. So obviously in question A, your answers will vary. In B, in the answer key, it shows that it is 0.6, but you probably just wrote 3/5 for the slope. So it was going up 3/5, up 3/5. So again, you may have had different work than this one says. The equation was y equals 3/5 x. If you put 3/5 versus 0.6, that's fine. Sorry, I'm just going to itch my nose. Then you had to sketch the graph. You have the equation for A is y equals 3/5 x. The coefficient is 3/5. The coefficient tells you the line steepness, and the coefficient tells you the stairs steepness. So those last two questions were a little confusing, but I think we got it now. So the ACE, I'm just going to click through these. If you want to look closer, you should pause your video and look at the answers. I will show you at the end of this video where the answers are located, but I will put them at the beginning of each lesson if you want to go through them. And again, just pause the video. I'm not going to read through them because some of you don't want to watch that. All right, so today we are talking about finding the slope of a line using the y-intercept and the slope of a line from the data in the table, a graph, or an equation. So still thinking about the stairs, the method for finding the steepness of stairs suggests a way to find the steepness of a line. A line drawn from the bottom step of a set of stairs to the top touches each step at one point. And you can see how that is. And you can see how that is in that drawing. You can see where they touch it, right? So that's just showing how this is relating to the line. The steepness of the line is the ratio of rise to run, y to x, the change in the vertical change to the ratio of the horizontal change. We call this the slope of the line, also known as the coefficient of x, also known as the constant rate of change. Does the slope change if we take 2 stairs at a time? Probably. No, I'm sorry, it does not. It does not change. The slope does not change no matter how many jumps you take at one time. And the last part said, does the slope change between any 2 stairs? Usually not. In the case of stairs, sometimes you'll find like one that's really small at the top or really big at the bottom to accommodate for the change in the building, but that's not very common. All right, so I did also figure out how to draw. I do not have a mouse yet, so my drawings are really bad, but I want to show you again, the equation is change in y over change in x. And so that is written like this for this equation here, y2 minus y1 over x2 minus x1. So if you were to write that like a fraction, it would just be y2 minus y1 on the top and x2 minus x1 on the bottom. And some of you are going, what are you talking about? What is x2? What is x1? So again, you're looking at points on a line. So if you were given 2 points on a line or 2 points in a table, you could use this equation to find the slope. So you might want to write this down. Again, you can pause the video. y2 minus y1 over x2 minus x1. And I'm going to show you in just a second here how to do that using actual numbers. So unlike the steepness of the stairs, though, the slope of a line can be negative. To determine the slope of a line, you need to consider the direction or sign of the vertical and horizontal changes from one point to another. So it's really annoying that my drawing is back there. So I might have to move myself to the bottom. All right. So the slant upward, look at this yellow part down here. The slant upward from left to right as a positive slope. So again, if you draw a line on a graph and it goes that way, that is a positive slope. The change is going up. If you have a slant downward from left to right, that is a negative slope. In that, if you had a certain amount of money, right, and there's the Y and the X, and you started with $100 and you spent a certain amount of money each week, you would have a negative slope. And then, give me this. So in the situations, they all are linear relationships. For each graph, describe how you can find the slope of the line. So here's what I'm talking about with this X1 and Y1. So we're going to look at this top one here. This is a positive slope going up to the right. So we have two X's and two Y's, right? Because we have 2 points on the line. The first point is 2, 5. That is 2 comma 2. They have this written funny. So the first point was 2, 2, right? And the second point is 5, 2. Oh, 5, 4. You see that? 5, 4. So the second point was 5, 4. So these are my coordinate points, and I'm going to use that equation. y1 minus y2 minus y1. All right, so how do I know which y is 2 and which y is 1? I'm going to tell you a secret. It doesn't matter. So here's my y's, right? I'm going to choose this one as y2 because I like positive numbers better. So I would do 4 minus 2, right? Take my y's. And then I have 5 and 2 for my x's. Now here's where it matters. Whichever y I chose for my 2, I have to choose the same point here, right? Because I chose 4 for 2 here, I have to choose 5 for 2 now. So then it would be 5 minus 2, and I will magically get my slope here. I will do 4 minus 2 is 2, and 5 minus 2 is 3. So my slope is 2/3. Does that make sense? Okay, you could do the same with this. You can do the same thing with a table. You pick 2 points, right? We have an X and a Y. We could pick 1 and 6, and we could pick 2 and 9 and use the same formula and plug in the numbers. Information about a linear relationship can be given in several different representations, like a table, an equation, or a contextual situation. So in your work today, it is telling you at the top, all graphs, tables, and equations are linear relationships. That's telling you you can use that magical equation, y equals mx plus b, where m is the slope, m is the coefficient, m is the constant rate of change, b is the y-intercept, right? So on the table, you're finding the y-intercept by where does the line cross y? I'm sorry, I said in table, I meant in graph. In the table, the y-intercept is where x is 0, right? Because that's where it's crossing. The y is where y is 0. Okay, and what do you know if it doesn't have one listed? What is the y-intercept? 0. Okay, so for each of these, you're going to find the slope and the y-intercept. And for the graph and the table, for these 4 up here, you will be also writing an equation using y equals mx plus b. In 4.2 problem B, they give you 2 points. You need to find the slope, find 2 more points. In question C, it gives, John has something he notices. You need to see if he's correct. Then here you need to talk about what is the slope of a horizontal line. Remember, horizontal goes this way, vertical goes this way. And compare your methods for finding the slope of a graph, a table, an equation. How are they different? Okay. So this last one is kind of a no-brainer. How is the constant rate of change of a linear relationship related to the slope of the line? That should be a no-brainer. Okay. And then you have some homework to do. So I promised I would show you where the homework answers will be. So when you're going into moving straight ahead, you will go, I moved them now. So they are in investigation 4 inside the lesson you are on. And I also took off the must watch of these videos. My video will always go at the top. I will really, really encourage you to watch my videos. These are optional. These ones will give you more information. And then right here is the key. So use that as you want to correct your work, or if you're really stuck and you can't get a hold of me. And then don't forget also there are some IXL links here for you to practice. And the IXL, I'm suggesting that you go to 80 to 90% mastery. If you try to get to 100% mastery, you'll be spending your whole day on IXL. So that's what I got for you today. I hope everybody is doing well, and I will talk to you soon.